Today we're gonna do a proof. The Hatfield and McCoy families are feuding over some land. Neither family will be satisfied unless the two triangular fields are exactly the same size. You know that C is the midpoint of each of the intersecting segments. Write a two-column proof that would settle the dispute. They give us that C is the midpoint of segment AD and segment BE. Segment AD and segment BE, C is the midpoint. And we have to prove that the triangle ABC is congruent to triangle DEC. Right there. Okay. Write a two-column proof. Our statement and our reasons. Okay. We always start with our given. C is the midpoint of segment AD and segment BE. Given. Okay. If C is the midpoint of segment AD and segment BE, then we can say by the definition of the midpoint that AC and CD are congruent and BC and CE are also congruent to each other. Well, BC is congruent to CE and AD. AC is congruent to CD. Okay. We can write that down. AC equals CD and BC equals CE. This is the definition of the midpoint. Okay. If the definition of midpoint says that these are congruent, these are equal, then it also tells us that it's also congruent. Segment AC is congruent to segment CD, and segment BC is congruent to segment CE.
I'm confused. So why can you write that segment AC is congruent to segment CD?
If the measures of two objects are equal, then we can say that the objects themselves are congruent to each other.
Oh, I get it now.
Okay. Okay. Now, if you turn the picture to one side, you can see that these are vertical. Yeah, the triangles are vertical. Okay. For number 4, if the triangles are vertical, then we can say that the two measures of the 2 points that connect right here, right there, the two measures are congruent. I am sorry, the angles are congruent. Sorry for that. So, angle ACB is congruent to angle DCE. ACB is congruent to ECD. And that is because of the vertical angles theorem. And if you can see in the triangles, we have angle, side, angle. So, I am sorry, side, angle, side. And that could be number 5. And that proves our given. Triangle ABC is congruent to triangle DEC by side, angle, side. Ta-da!